All right, section 1.3 is going to talk about linear equations. So a linear function is a line. So it's a graph, it has a constant rate of change, it's going up and down. Slope-intercept form of an equation looks like this. Ax plus b, you might have also seen it as mx plus b. A or m is the slope. That's your rate of change, how fast it's going up and down. B is your y-intercept. It's where it crosses the y-axis on a graph. It's also the initial value or the starting value when you're talking about a word problem. The solution to a linear equation is any ordered pair. It's not spelled right. There we go. So xy that makes it true, that makes the equation true. So that's any point on the line is if you plug it in, the equation's true. Graph on the calculator. It's the easiest way to do this. We're going to use those graphing calculators people bought or use the apps, whatever. If you hit y equals, that top left button brings you into that menu. I've shown you that. X's are going to be in that button next to the alpha, so it's right next to the green button. This button will give you an X. If you want to see the graph, you hit graph. If you want to change the window, we'll talk about that in a minute, but there's a window button in that top row that allows you to adjust how you're zooming. And there's also a zoom button that will allow you to zoom in more specifically. All of those buttons in that top are going to help us. The other one is trace. If you have a graph and you hit trace, it just lets you move a point with your arrows and gives you coordinates on the bottom. If you hit second trace, second is the blue button, and then trace, you have some options in here. Value means you can type a number in for x and it'll tell you the y. 0 means your x-intercept, so you can find the x-intercept. Min and max won't really help us with lines, but we'll see it later. Y-intercept, you would plug 0 in as a value. So all those gray buttons at the top of your calculator are really helpful when we're graphing. All right, let's look at this word problem and turn it into an equation. A 100-gallon tank is emptied at 5 gallons per hour. So our initial value is 100. We have 100 gallons in the tank. That's our x-intercept. We're emptied at 5 gallons per hour. So we're taking out 5 gallons per hour. That's why it's minus. And that's what happens over and over again. So that one gets the x. Now, linear equations, you also might see something like y equals 5. That's the same as saying 0x plus 5. So really, it has a slope of 0, which makes it a horizontal line. Horizontal. So the line would be like this at 5 on the y-axis. X equals 5 would be a vertical line. That's going to go up and down at 5 on the x-axis instead of the y. Now this slope is undefined because if we made it a fraction, it would have 0 on the bottom, which you can't have. You'll also see me write it like this, which is like null set, no value that works. So those are your linear functions. Domain, if you remember from 1-2, is all x values. Lines go on forever in both directions, so the domain is negative infinity to infinity. And they go up and down in both directions, so the range is negative infinity to infinity. Now, if we're talking about a comprehensive graph, so if I ever say, hey, draw a comprehensive graph, that wants you to include all the intercepts. So you have to show all the x and y intercepts. Show any maximum or minimums if there are any, and show the end behavior. We want to see what's happening on the edges of the graph. So for example, if this was our graph, like this, and on the calculator we could only see this part, that doesn't really help us. Let's say that's the x and y axis. If all we can see is that red square, we don't know what's happening on the right end. We can't see the y-intercept. We don't see all the x-intercepts. That's not a very helpful graph. All right, now let's put those back in here. So now if I zoomed in like this, now I can see all the x-intercepts. I can see the y-intercept. I can see the maxes and the mins. And I can also tell what it's doing at the ends. So that would be a comprehensive graph. If I wanted to zoom in on the calculator, what that's going to do, that's where we do our window. We decide what x value this is, what x value this is, and then we do the same thing for the y's. And then we use that window button and we type those in so that it zooms this screen to show the whole graph. We'll use that more later. It's just an introduction right now. Let's go back to linear, where our slope-intercept form of a line is y equals mx plus b, or y equals ax plus b. The calculator is going to say a. That's why we're doing this. All right, so if I have a line, it's asking us to find the slope. So to find the slope, you have to find 2 points. Then you count your rise and your run. So here we actually go down 1, so it's -1, and then run is over. So over 1, 2, 3. So our slope would be down 1 over 3, or -1/3. X-intercept is where it crosses the x-axis. So on this graph, it's -3. Y-intercept is where it crosses the y-axis. So that's -1. And then we can write our equation using the slope and the y-intercept. We just said the slope was -1/3 x, and the y-intercept was -1. So that is the equation of that line. This also works in reverse. If we're given an equation, we can pull the slope out. It's what's with the x. We can pull the y-intercept out. It's what's at the end. And then let's graph that. So I'm going to start at 4 on the y-intercept. And my slope is 2/5. So I go up 2, right 5. Do it again. Up 2, right 5. And I can also go in the other direction. Now I have an entire line. So there's my line. And for the x-intercept, we just have to figure out where it crosses the x-axis. And in this case, it's -10. So that is our linear information. It's section 1.3. Let me know if you have any questions.